Welcome back to Destin Learning. Today, we're tackling an important concept in Python programming: error handling with try except. Errors are a natural part of coding, but they don't have to stop your programs from running. With Python's try except blocks, you can gracefully handle errors, allowing your program to recover or provide meaningful feedback to the user. This makes your code more robust and user-friendly. In this video, we'll learn how to use try except to catch and manage errors effectively, so you can write programs that handle the unexpected with ease. Let's dive in. Error handling is crucial in programming to ensure smooth execution. Python's try except construct helps catch and handle exceptions, preventing crashes. Proper error handling enhances user experience, reliability, and debugging. This guide covers its importance, usage, and examples. Error handling is crucial in programming to ensure smooth execution. In Python, common errors include dividing by zero, accessing non-existent files, and using invalid data types. The try except construct in Python helps catch and handle exceptions, preventing crashes. Proper error handling enhances user experience, program reliability, and aids in debugging and maintenance. This guide covers the importance of error handling in Python, how to use try except blocks, and examples of handling various exceptions. Error handling prevents program crashes, improves user experience, facilitates debugging, supports graceful recovery, and ensures data integrity. The try except block in Python is used to handle exceptions. The try block contains code that might raise an exception, while the except block handles the exception. This slide covers various examples of exception handling in Python, including handling division by zero, multiple exceptions, catching all exceptions, using else with try except, using finally to clean up, and raising custom exceptions. This slide presents an example of handling division by zero. This slide discusses handling multiple exceptions in programming, specifically when a user enters zero. Catching all exceptions can be useful for logging errors. However, it should be used cautiously to avoid masking bugs. The else block in a try except structure executes only if no exception occurs. It is used for code that should run only when no exceptions are raised. The finally block is crucial for cleanup tasks as it runs whether or not an exception occurs. It is commonly used for closing files and releasing resources. In this example, we learn how to manually raise exceptions in Python using the raise keyword. The output is shown when the user enters -5. To handle exceptions effectively, catch specific errors, avoid overusing generic exceptions, and use finally for cleanup. Provide clear error messages, log errors for debugging, and handle anticipated errors gracefully. This slide covers common error handling scenarios including file operations, user input validation, API requests, database operations, and arithmetic operations. Handling file errors gracefully is crucial to prevent crashes and improve user experience. Common errors include file not found and permission denied. Use try except blocks and provide informative messages. Follow best practices like logging errors and managing resources properly. Error handling with try except in Python ensures robustness, user-friendliness, and maintainability. It prevents crashes, guides users with meaningful messages, and maintains data integrity. The use of finally and else blocks, along with custom exception handling, provides flexibility for complex scenarios. Mastering error handling is crucial for developers. It improves program stability and user experience. This guide provides best practices like using try except blocks, handling specific exceptions, and logging errors. Examples illustrate graceful error management. In summary, error handling in Python is crucial for creating robust and user-friendly programs. Using try except blocks prevents crashes and provides meaningful messages. Additionally, finally and else blocks, along with custom exceptions, offer flexibility. Mastering these techniques improves stability and user experience. That's all for our session on error handling with try except in Python. Today, we explored how to catch and manage errors gracefully using try except blocks. By implementing error handling, you can make your programs more robust, reliable, and user-friendly, even when things don't go as planned. Thank you for joining us at Destin Learning. If you found this lesson helpful, don't forget to like this video and subscribe to our channel for more Python programming tutorials. Keep practicing, stay curious, and we'll see you in the next session. Happy coding!